Hi everyone, today we want to talk about the oxidation of alcohol. And alcohol we have various types, which is primary alcohol, secondary alcohol, and tertiary alcohol. And primary alcohol will give us the aldehyde for oxidation, whereas the secondary alcohol will give us ketone, and tertiary carbon will have no reaction. And the reason lies in the hydrogen on the carbonyl carbon. So let's dig into it. So at first, the oxygen of the primary alcohol will attack the partial positive Cr, and then to give back the electrons to the oxygen, which is something looks like this. And as a result, the product will be, and from now on, this oxygen will be positive. So we will have another water molecules, and this water molecules is going to deprotonate the positive oxygen and giving us the product as this. And remember that we want to eliminate this big bulky group. So this another water molecule is going to deprotonate the hydrogen or from the carbonyl carbon and give the double bond to the pi bond to the oxygen. And then we need to eliminate this bond to Cr, and the pi electron will move up to the oxygen. And as a final product, our product will be something which looks like this. So this is our aldehyde, but eventually it actually is not the aldehyde being oxidized to carboxylic acid. It will form a compound which is known as hydrate, and here's how it works. So this oxygen is going to, so it has two lone pairs, right? So it's going to grab a hydrogen from the sulfuric acid and then give us, and the electrons will give to this S and give us this compound, which is the OH, and this OH is positive. So now we can give the water a chance to the carbon, attack the carbon, so the electrons from the oxygen, and this double bond give to the oxygen, the pi electrons, forming a compound which looks like this. And eventually this oxygen is positive, so now we have another molecules OH2 to deprotonate the hydrogen and bring electrons to the oxygen and form a compound which looks like this. And as you can see here, just now we learned about it, which is a very important step, which is the elimination of the hydrogen that attached to the carbonyl carbon. So now we have this compound which is known as hydrate, and it also has the hydrogen to be eliminated, so it actually can be further oxidized into carboxylic acid, and this is why it can undergo further oxidation, because it has this hydrogen. And if you look through the whole process, it actually reversible up until it further oxidized by the carboxylic acid. Until it further oxidized to carboxylic acid, the reaction is totally irreversible. So the hydrogen is very important, specifically the hydrogen that attached to the carbon, which is attaching the hydroxy group. So in this case, primary alcohol, it has two hydrogen that attach to this carbon, which is adjacent to the hydroxy group, so it can undergo two oxidation process. Whereas the secondary alcohol only has one hydrogen that attached to the carbon that are adjacent to the hydroxy group, so it only can undergo one oxidation process, which is forming a ketone. And when you look through the tertiary alcohol, this carbon, it does not have any hydrogen that can be eliminated, so therefore oxidation process will not take place. And this is why tertiary alcohol could not undergo oxidation process, because the carbon that adjacent to the hydroxy functional group does not have hydrogen to be eliminated to form a double bond. And the requirement of this reaction would be the John's reagent, which is the oxidizing agent, and also the H2SO4 under reflux condition to ensure that the aldehyde is being oxidized further to form the carboxylic acid. So that's all for the video. Thank you.